So we have seen the two-dimensional graph. For two-dimensional and three-dimensional graphs, we can use plot command for two-dimensional, surf command for three-dimensional. We have seen the linear space for plot command. We have seen the font style, colors in the previous videos. Now we'll see in this video three-dimensional plot, which requires surf command and the function feval. So let us open the side notes. This is the function z equal to f x comma y. Arguments or input variables are x and y. This function z is equal to 2x square plus y square, an end function. So this 2x square plus y square is elliptical paraboloid equation. We can use x square y square so that it will become spherical function also. So any function we can give three-dimensional function. Here x and y are used with the help of linear spacings. If they are generated, x is -1 to 1 with 100 divisions, 100 points, and y is -2 to 2 with 200 points. Lin space is used function for generating x and y. So x is a vector, y is a vector, and we evaluate E of eval. We are passing x and y vectors and the function f to evaluate. This will give z. Z is a matrix of dimension m by n, where x will be vector of n and y will be vector of m. So z will be matrix of n by n. So the dimension of z is a matrix with elements, suppose z ith element and jth, we can say zij. So corresponds to the height of the points with x coordinate xi and y coordinate yj. So whatever the xi is there from vector x and whatever yj is there from vector y, corresponding to these two, according to this equation, the height zij will be calculated to plot into three-dimensional graph. We define the function f to calculate z, f eval x, y, f. So that f function is whatever the three-dimensional surface we want, where f eval returns the m by n matrix whose ith and jth element is f x I comma yj, okay, which will be transposed by using a single quote symbol. Single quote symbol is used after the matrix bracket. So here line number 6, this single quote symbol is used in front of immediately after closing bracket, so that xyf bracket will be transposed. So bracket transposes with the matrix transposes with the single quote. And then we execute the surf function. Surf function gives surface creation with x, y and whatever z calculated. So let us save it and execute. We'll select prog 1 only, replace file. And this created the three-dimensional surface. Okay. So this three-dimensional surface we can zoom, we can rotate, we can zoom it, and so this is one plane selected, and this is in these tools we are having zoom as well as 3D rotation. We can rotate it. So in this way we can zoom it, we can rotate it. So this surface is zoomed, and if you want to zoom out, we can click the zoom out tool. Okay. So this is zoom and rotate. Okay. So this is the one three-dimensional object creation, a graph creation. So instead of surface, we can draw the curves in the space. Let us have this program. In curve in the space, we are having suppose one vector t, line space 0 to 4 pi with 100 points is taken, and the function used is param 3D, param 3D. So this draws the curve with three different variables inputted, and these three different variables are three vectors with equal size. Here the t is firstly line spaced or vector generated with 100 different values. This vector is given to the cos function, this is given to the sine function, and itself it is used. So cos of t, sine of t, and t is plotted. So three different vectors will be generated. Cos of t is one vector, sine of t is another vector, and t is itself is another vector, one more vector. So these three vectors are having same dimension, and these are given to the param 3D, and let us check the result. We have executed. So this is overwritten. Okay, so this circular graph is in. Let us put the CLF and then save and execute. Then we can observe this graph. This is three-dimensional curve. Okay, in the space. So this is curve in the space. Similarly, we can use some statistical graphs also. So this is bar graph. Bar graph can be drawn with the command bar, bar. For that we have to have the data. Say x is equal to 1 to 10, different points are there, 1 to 10, and n is corresponding heights or values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values are there. 8, 6, 13, 10, 6, 4, 16, 7, 8, 5. These are the heights of the bar. Then clear figure is there and bar x comma n is given. So x is the x-axis and n is the height or amplitude. Let us execute. This is statistical window, statistical figure. So maximum value is 16. So up to 16 the scale is there, 0 to 16 on y-axis, and on x-axis 0 to 10 are there, 1 to 10 is required. So this is statistical graph, bar graph. So two different data can be shown in the same bar graph. So to have the two bar graphs side by side, we should have two different data. So let us see x is equal to 1, 2, 5, n1 is equal to 5, 10, 5, n2 is equal to 6, 8, 7. So 1, 2, 5 are the x-axis data. n1 amplitude, vertical value 5, 10, 5 corresponding for n2 6, 8, 7. Now while drawing two bar graphs, the n1, n2 should be the column vectors. So that's why n1 is transposed with the single quote, n2 is transposed with the single quote and put into matrix as a two columns, and x is given 1 to 5. Let us save and execute. Two bar graphs will be there. Oh, Scilab older graph is also present here. So let us put CLF, save and execute. So now older graph is removed. So at 1, at 2 and at 5 graph is present. 1, 2, 5. 3, 4 graph is not present. So at 1, 2 values are there. One is 5 and one is 6 value. 5 value, 6 value from n1 and n2. At 2 the values are 10 and 8. So maximum 10 is there, so maximum scale is 10. And at 5 it is again 5 and 7. So 0 to 10 scale is there on y-axis and 0 to 5 scale is on x-axis. This is about the plotting of statistical data, statistical graphs, bar graphs. Thank you.